Next, I'm going to make the little collar here with the knurl on it, and remember the big graduations here. This is 1-inch aluminum, and the first step will be to put a knurl on here. I'm going to use a real coarse knurl. I've got coarse knurling rollers already in my Brown and Sharp holder here, and you might remember that I've used this in, well, not this exact one, but I've used this one in several videos. This is really turret lathe tooling, and I've talked about this before. Brown and Sharp product, but this is the next larger size that will accommodate 1 inch up to perhaps 1.25 inches or so. And I need about 1 inch of knurl on there. Some of it is going to be machined off, but you know, I always like a little extra. So running the machine at 350 RPM and using plenty of oil, and I've even got a rag down here to sop up some of the oil. I'll use power feed. So let's get started here. At this point, I've stopped the machine with the clutch, and I am shifting the feed reverse lever into the other position to feed out, that is, toward the tailstock. And even though the cutting has pretty much been done, I still want to use oil. That'll flush away the swart. Let me clean it up and we'll take a look. And there it is. You can see I got a nice crisp, sharp diamond knurl. All ready for the next several steps involved in this little part. It's one of the more complicated parts, really. Well, the most complicated part in this little project. Continuing on the knurled nut, the next operations, and I have the work held in the 3-jaw chuck of the Knurling lathe, will be to center drill it to the tap drill size, and then tap it, after which I will turn it down here just a little bit, and that's where the graduations will be, just enough to take the knurl off, and then I'll cut it off. Here we go. And now a pilot drill, 1.25 inches deep. That's about a 1/4 inch bit. I'm not sure what size. This drill bit is a 25/64. That's the tap drill size for a 7/16 20. And I don't need to mark this. I just drill in until I feel the bottom of the hole. This is a 7/16 bit, and I'm counterboring it only a 1/4 inch deep because I don't want the thread really to run the full length of the piece. Next, I'm going to tap it 7/16 20. That's fine, because I want that thread to go all the way to the bottom of the hole. This is a tapered tap. Now I'm using a spring-loaded tap follower here. That's the one I made in another video. I did tap this by power in the prototype, and it worked fine, but I do have it does have a tendency to slip in the chuck, because this is very hard steel held in hardened jaws, and I do not have a tap holder, but it does tend to slip. So I'll just tap this, and make sure you do this type of operation in a lathe, and that assures you a straight thread. If you do this in the bench vise, it's fairly likely you'll be crooked. And I'll go all the way to the bottom of the hole. What I'm going to do now is remove the knurl 3/8 back. Now that's the surface where the graduations will be and the numbers. And of course I can't stamp that on a knurl, so I will take it down just to the point where there is no knurl left. 3/8 long, I said. And last but not least, I will cut it off for a total length of a little bit over 3/4 of an inch, because I will trim it to the exact length eventually so it fits exactly in the carriage stop. Continuing on the dials, I have knurled it, turned it down, faced it to length, threaded the inside. Pretty much done except for the graduations, which is no small job because I've been working on this for a couple hours just with the setup. But I have to put graduations like the original South Bend, or rather Atlas part. Now I'm going to do this with an index head or dividing head on the Bridgeport mill. Probably nobody in the entire world is going to do that, or even make this for that matter. But remember, the alternate way of doing this, and it is probably easier, is shown in these videos 177, 8, and 9 when I made the larger dials for the Logan lathe that looked like this. And a lot of you have seen that. So I believe that's an easier way, because how many people are going to have a dividing head? Furthermore, this is a hard-edged dividing head, and it has a 4:1 ratio rather than a 40:1 ratio. So what I'm going to tell you here might be of interest, but you're probably not going to actually do the operation. So what I have to do here is divide the work as I rotate it into 50 parts, because we're going to have 50 graduations on here. And I already did a dry run, a practice run, a rehearsal using a Sharpie. Perhaps that shows up. I didn't do any cutting, but I just wanted to proof my calculations and so on, and show you that you should do the same in a job where you don't want to spoil the work, because if you have one graduation wrong, you got to go back and make the whole part over again. And that can be extremely discouraging. But the work is held on one of the threaded rods that I made, and held in a 7/16 5C collet with a hex nut there, locking it in place. Now let's take a look at how I'm going to actually divide that circle. Real quickly now, here's the calculations for those of you that may be interested, and here's the formula, which the 4 stands for 4 revolutions here of the crank turn the work 1 revolution. So it's 4 over the number of graduations, which is 50 graduations. So it's 4 over 50. I can reduce that to 2 over 25, and then also convert that to a fraction that has the same value, and that would be 6/75. Why? Because I needed to find a circle, and there are 4 plates for this, that we'll have the number. Now there is no plate with a 50 or with a 25, but there is a plate with a row of circles that have 75 holes. So I'm going to use the 75 hole disc, and in fact move it 6 spaces, or to the 7th hole, for each graduation on the dial, or 6/75. I know that's about as clear as mud. As you can see here, each time I turn the crank one turn, I have turned the work 1/4 of a turn. So in other words, 4 cranks turns the work 1 revolution. Okay, there's a sector on here, and I have set that so it spans 7 holes, which is 6 spaces, and that can be rotated around. My home position, and there's a little plunger here with a point on the end. I'm in the home position at the top, and I'll scribe one line, and then I will move it up to the sector, scribe another line, move the sector, and then bring it around like this, and so on 50 times, which is quite tedious. Now notice there's different rows of circles here, or of holes, and I'm using the 75 row of circles, which is the second from the end right here. And it's pretty much ready to go now. I know that you're not following that. And then I'm going to take the Sharpie out, and I just ground this tool 60 degrees, and this is just a dowel pin, hardened dowel pin. So I'm going to be scribing. Also, I should say that some of the graduations are longer than the others. So every 5th one is longer. Kind of like this dial. And this one has 100. So if you look at that video, you're going to find that I used a 100 tooth saw blade, circular saw blade, as my index plate. And if you would make this project on a lathe, Logan lathe, let's say, you would use every other tooth on a 100 tooth saw blade, since you probably will not find a saw blade with 50 teeth. Let's move on. Looking at the work from this direction, I have centered the tool so it's on the center line in the y-axis of the work. And as far as the depth is concerned, I'm cutting at about 20 thousandths deep, or scribing. Remember that I will not turn the motor on. This is just a scribing operation, but it's about 20 thousandths deep. It will leave quite a burr, or a furrow, as I make the cuts. Let me move around to the other side. As far as the length of the graduations, the short ones are 100 thousandths long, and every 5th one, the long ones, are 200 thousandths long. I've already made 2 graduations. Now I'll be watching the DRO, which you cannot see in your view, but I am now scribing one 100 thousandths long. Very tedious work, and now I'm going to rotate the work 1/50th of a turn. That's kind of tedious. I do have to use my little flashlight and my magnifier to do it, and that's why I'm working so slowly. And now the next one, also 100 thousandths. And yet another one. I moved the sector. $100 thousandths. This is one I should do in time lapse. And now this is the 5th one. I'm going to move up to the next hole there. Now this one will be 200 thousandths long. And my tool is working pretty well. It's about 15 minutes later, and I just have 2 graduations left to scribe, and it's always a little tense as you get near the end here. Will it turn out right? Same as cutting a gear. And this is where your error will show up. You may not notice it till you get near the end, and I'm advancing it one last time. Oh, that's a relief. Did you hear me sigh? That's it. Quite a few burrs, so it has to be polished, and I still need to put the numbers on there, which I'll have to hand stamp, and will not come out real nice because it's I'm not going to make a jig or a fixture to do that like I did for the Logan lathe. But I'm done now on the Bridgeport with one of them for the prototype, and of course I got another one to do off camera. Well, the dial fits in just fine, but I tell you, I'm not proud of the stamping job that I did, and I bought these little stamps, cheap ones, but the problem is that they're only 1/16 inch in height, but I believe that's about what they are here. And they're very difficult to see on the original, and even harder to see on mine, and they're stamped on there about as crooked as a dog's hind leg. That one's really out of whack. That one's not too bad. But they're so small I can't see them. The 0 is good. Matter of fact, that's the only good one. But you get the idea. I need a fixture to do that. Alright. Now back to the other parts. The next step here, and you may recall that I cut this off extra long. I need to reduce its thickness to 749 thousandths, which will allow it to fit perfectly in the carriage stop. Now, if it's too sloppy and is allowed to move back and forth, you may get inaccuracies. So we want a good fit. And how do we take something down to the exact dimension? I think the best way is this way, and I'm using the hard-inch lathe, which I haven't used in ages, but you can do this on any lathe and set your compound for 90 degrees like this, and then you can feed, and this is an extremely accurate lathe, with your compound handle, dial, and feed in however many thousandths you need to. Now notice how I've got this set up in the 3-jaw here, and the reason I'm using the 3-jaw instead of the collet is that this allows me to take an accurate measurement with my micrometer. So I've got room for the frame, and you could use a dial caliper as well. So I'll take an initial reading, see how many thousandths I need to take off, rough it down to the approximate size, and then finish it off by facing it to 749 thousandths. Alrighty. Take a cleanup pass. And I have 758, so I got about 9 thousandths to go. And all I need to do is to, pardon me, feed in the compound here 8 or 9 thousandths, and I might take 2 passes. I love the white large dials on this machine, so easy to read. And I'm at 752, So I need to take one more pass off. I'll do that off camera, and then I will break the corner like this. And that's it for that piece. Let me take it out and see if it fits, and it should, because I measured it. And it does, and it's a very close, tight fit with no slop at all. Okay, I'm getting near the end, and I have only one piece left to make, and that is the clamp piece on the bottom, and this is the original one I made in earlier videos. But since this is repetition, and I've already done this in tips number 368, what I'm actually going to do is show you the footage from that tips. So I'll be making this one that you see right here, but when I reappear live in 10 minutes, I'll actually have made one from this hot rolled material, which is all I have in stock, and it'll be mounted on the final one here. So I'll see you in 10 minutes. Watch these older clips, which is still valid, and it shows exactly how the clamp is made. After searching around the shop, I did find a piece of steel that is not hot rolled, so I'm going to use it, and I've already laid it out, and I'm going to cut it off. Here's the dimensions. It's 2 inches by 1.5 up to the line, so I'm going to saw it off to that. Now this is a 3/8 thick right here, and so is this piece, in fact, and I would recommend that you use a piece that's 3/8 thick. But for some odd reason, I found this in my junk box. This piece is 4/37.5 thick, and I don't know why it was marked. There must be a gauge or something, but I hope it's not too hard for me to saw and deal with. But that is the stock that I'm going to use for this clamp. So I'll be right back after I saw this and I mill it to 1.5 approximately. Now, I've been getting an awful lot of comments from people saying, well, why didn't you do it this way, or why didn't you do it that way, or I don't like the way you did it. But remember that when you're machining, it's like mowing the grass. I mean, you can mow it any old way you want, and at the end of the day, the grass is mowed. And it's the same with a machine shop project, that you can use your own creativity. You do not have to do it exactly the way I do. If you're a brand newbie to machine shop, it might help if you do it in a similar manner, because you haven't been able to experience things yet that allow you to make these decisions. But you know, just go along with what I'm saying here. So be back in a minute. All right, that piece was as soft as butter, so it's milled down to 1.5 inch by 2. Now on the 2 inch, I failed to tell you moments ago that in fact this piece is less than 2. Why? Because of the setback that is necessary for the lathe bed. Remember, the rack is under there. I showed that to you earlier. So ultimately I have to take off another 1/8 of an inch off of here, but I'll do that later. Now, I know that this could all be laid out, as far as the holes are concerned, with the drawing, if there is a drawing, or just with the layout. But, you know, I love to transfer holes, because then they always fit. So here's how I'm going to do it, just by taking the two pieces together. Now, normally, if you put two pieces in a vise, only one piece is going to really be held. I think you know that. But for some reason, these two pieces are equally gripped, either by sheer serendipity or the fact that there's some wiggle here on the movable jaw, and it's probably the latter. So now I'll simply take my transfer punch, which is 5/16, and transfer those two. And I notice I set it on the wooden table here. Someone got very angry at me for doing some gentle wrapping on my granite surface plate, even though this is from Grizzly and only cost $25, and if I ruined it, I would only have a minor anger about it. Minor. Now you see those two holes. You do that any way you want. there they are. And if I don't let the drill slide off, that is, if I truly drill the holes, and it will line up if I drill them accurately. Now I always take it over, and I don't always show this, and I pre-drill them on my micro drill press with a 16th inch bit, and that just ensures, in effect, I'm deepening the center punch holes. I know I'm over talking here, but that's why I do things, and then it works. If you take those extra little steps in your workmanship, your craftsmanship, things will work. They won't fail on you. Now I'm going to drill those, and I won't show that. They are to be, in fact, drilled. Well, I always pilot drill them, so 16th inch, then about 3/16 all the way through, and then 1/4 inch, which is in fact the tap drill size for 5/16 18. See you in a minute. Okay, those holes are drilled. Now let me point out one other thing here, and there may be no need, but I like to use this block as a tap guide. In other words, I'm going to tap right through this and into this other piece. Why am I making a big deal about that? Because if you tap these holes even 2 degrees off of square, they tend to bind on you later on. But my point here is I'm going to tap right through this piece, so it's a tap guide now, and into the other one. And then when I'm done with that, I'll put a bolt in there and tap the other one. Then I am absolutely assured that they line up. A bit overkill, possibly. Okay, one hole down, and notice I put a bolt in there, and do that if you feel like it. And then I'm tapping the other one. And that's 5/16 18. That way I know darn well that the holes are, the tapped holes are perfectly perpendicular. Okay, the holes are tapped, and the screws turn freely, no binding whatsoever. The next thing I need to do is to take 1/8 of an inch off of the end, right where my finger is, and I've already set the height gauge. Get yourself a height gauge if you don't have one. There's the layout line, and I think I already explained why. I need 1/8 of an inch off because of the rack on the bed of the Atlas lathe. So I'll take that over and mill that off on the Bridgeport. Okay, the 1/8 inch is off. Now you want a little wiggle room so it doesn't bind, and that was accomplished by drilling those 2 clearance holes just slightly oversized. Now the next thing, and possibly the last thing I need to do, is to put this step in. So let me lay that out real quickly, and we'll be done. Looking at the prototype, the step here is 1/8 inch deep, 1/4 inch wide. I've already put bluing on the part, and with this gauge set at 1/8 inch, that's the depth, although I will dial it in on the milling machine. And then as far as the step is concerned, 1/4 inch. This really should be up against an angle plate. Right there. Now the reason I put red on here is that the red part is the part that I want to remove down to that line, not the little piece out here. So be careful you don't mill the wrong piece, the wrong part off. Not that I've ever done that. At the Bridgeport, the work held up high on parallel so I can see the layout line. I simply bring the cutter, touch off, lock the quill, back off, I scraped a little bit, I don't care. Zero out the dial on the knee, and I think I'll take this all in one pass. So no, I won't. I'm going to take off 100 thousandths, then I'll take off the final 25 thousandths. So up I go, one full turn, which is 100 thousandths, and then I'll just mill to the line down here because that isn't very critical at all. And that's the last pass to the line. I will raise the table 25 thousandths and do it all over, and then I'm done milling here and I won't show that. Alrighty, I'm back. How did you like that clip? A little bit different than what I did here, and this is the one that I just completed. Remember, it's made out of 3/8 material rather than the 7/16 thick, which is just something I happen to have, and this is hot rolled. I would have preferred cold rolled. But it's 1.5 by a little bit less than 2. We talked about that in the other clip, that this has to be shorter for the because of the rack on the lathe. So that's ready to go. Again, this is the prototype, and this is the finished one, almost finished. Let me put it together and talk about it a little bit more. I think you will recall me talking about the fact that Atlas Craftsman lathes had 2 different thicknesses of beds. So for the 3/8, and that might be the older ones, I'm not even sure, let this represent the bed, and this is the setup with this bottom piece for 3/8. Now if you have a 1/2 inch, the idea here was that it could be reversed like on the prototype here, and that's more or less a fulcrum point, and that will accommodate the 1/2 inch bed. That's the reason for that. However, you could make this one way or the other depending on what machine. I do have one lathe of each thickness as shown in the other video. Well, here they are, pretty much finished except for stamping the numbers on the graduated dial. And since I only have the 16th inch ones and then 1/8 inch, I have to wait until I get some 3/32, which would be better proportion for the job. Now notice on this one that I put a 0 mark on there, or witness mark. Actually that was ground in with this, which is kind of uncontrollable, and then I put a little bit of red ink in it. But I found that on the final one here, it was a little more controllable to use a 3-corner file rather than the grinder. Another improvement that could be made is to round these corners, and that would be a 1/2 inch radius, because this is 1 inch thick stock. That would remove the knuckle buster business and possibly make it easier to turn this with the thumb without interfering with that corner. And they both operate nicely. Let's go over to the Atlas lathe. Works great. Over at the Atlas Craftsman lathe, they're all lined up like ducks in a row, and there's the original Atlas equipment. This is the one made in earlier videos that has no micrometer dial on it, just an adjustment here. And that was a series of videos, and as I told you, this is exponentially more difficult. And here is the prototype, ready to go into service, other than a good old number stamping. And I think I told you that I much prefer these nice square-headed bolts as far as the appearance is concerned. And this could be blued or finished off. I didn't spend any time polishing it. I particularly like the South Bend wrench. You can leave that hang right on there. So that completes it. I got enough stops here to carry me out through the rest of my life, although I do have 2 lathes. Hope you liked this rather long video build. Thanks for watching. This is Tubalcain saying so long for now.